All right, Hyperbolas Part 2. Can you guys make sure you have your notes out? When you came in, you picked up a review. Thank you. And then, could you also make sure you have your pink formula sheet out? Because, like I said, I'm a very tired lady, so I'm going to get my formulas all backwards. Help me out. We're going to skip this review question of just like graphing a basical hyperbola, and we're going to get to this guy first. So we're going to be completing the square, and then we're going to graph it. Hi, thank you. Brandon. Must see, go now. See? You started running too, didn't you? I'm already old. Alright, so completing the square in hyperbolas is super duper fun. Now, we already knew this was a hyperbola on this question, guys, because it's in the hyperbola lesson. But the reason I know it's hyperbola is because you have x squared minus a y squared term. So that's a dead giveaway you have a hyperbola.
So even if it's like x...
If there's something in front of the x squared, but it's minus y squared, or on the contrary, if it's y squared minus x squared, either way, it's a hyperbola. So
it would be like 1x minus 1y. It's still a hyperbola.
Squared.
Yes.
Yes. Alright, so let's complete the square on the x's. Now, normally on hyperbolas, we usually have something to factor out, but that's not the case in this x quadratic. So x squared minus 4x plus blank. Now, for the y's, this time when I go to complete the square, you do have to factor out not just a 4, but a negative 4. So that's why I think hyperbola is a little tricky. Jacob? Jacob? You know, take notes, watch, listen. I'll call you out. I'm going to make your parents watch this video. All right, y squared. Now be careful here. Remember, you factored out a negative 4. So this is now a negative 6y plus blank. We're going to move that 36 over. And then you're going to have to balance your equation out. So the plus blue and the plus red. All right, let's talk about the first blue blank here. Completing the square here, you take half of this and square it, and you still get a 4. And that is truly a 4, so it goes over here as a 4 as well. But this guy, while I write a 9 in the blank, what really is in that blank?
Negative 36.
Very good. Negative 4 times 9, which is a negative 36.
So it's 4.
Yeah. So this can now be written in its factored form of x minus 2, quantity squared. Leave the negative 4 out in front of this factor. And speaking of that, this guy's factored form is y minus 3, quantity squared. And then Daniel added these up for me already, and he said it equals 4.
Yes.
So not quite done. We have one more step to get into conic form. We're going to divide everything by a 4. So hyperbolas, I really want to see the denominators, even if they come out to a 1. So this guy, his fraction is going to stay as x minus 2 squared over 4. Minus, these 4's will cancel to a 1 over 1, but I still want to see that. So y minus 3, quantity squared, put it over 1, and then equals 1. We don't typically have an a squared or b squared value of 1. This just happens to be how it worked out today. So now I got to find everything. All right, well, let's start with center. Center is always located at h comma k, which is always x comma y. So x comma y would be 2 comma 3. Now I gotta find everything. And you guys know when I find things versus when I graph things, I don't actually use the things I find when I graph it conceptually, so it's okay. It's just a nice double check for me. Let's go find on our transverse axes, you're gonna find 2 vertices. So on this type of hyperbola, make sure you're looking at the right formula piece. This is a horizontal hyperbola. So the vertices, the formula for that is h plus and minus a comma k. Do I have the right formula?
Yes.
This is not a probably moment. You should double check everything I do today. So remember, we have h and k right here. So 2 plus and minus, wah wah, I never found a.
A equals 2.
Very good. This is a squared, so a equals 2.
0.
Yeah.
Child, what is b?
B is 0.
Child, square root of 1.
Which is 0.
1.
And 0.
You're just being weird. All right, 2 plus and minus. You guys just told me a was a 2. And then comma k from the center was 3. PreCalc, you're better than this. You can give me 2 ordered pairs. Yeah, this becomes 4, 3 and 0, 3. There's a lot of numbers going on here. So my use of color is intentional, not just because I like pretty notes, but because, man, it gets crazy. All right, foci would be the next thing I'd make you find. Uh-oh, you know what I forgot to find, though?
C.
I never found C. All right, there's a little formula on your formula card for finding C for hyperbolas. Hyperbolas, be careful, it's square root of a squared plus b squared. So square root of 4 plus 1 would be square root of 5. I don't care for decimal approximations on these. I'm just going to leave it kind of funky. Because the foci formula for this type of hyperbola is h plus and minus c comma k. So our foci would be at h, so 2, plus and minus, you just found c to be square root of 5, comma 3. I don't need you guys to split that one up, because they're like funky, weird little decimals, so the other thing I'm going to make you find would be the asymptote. Alright, so the asymptotes. You can pull that straight off of your formula card, but this type of hyperbola, the asymptote line, is at y minus k equals plus and minus. Now you got to make sure you're pulling the right formula. This one would be b over a. And again, I'm just stealing it right off the formula card. Times x minus h. So plugging in everything I know, that would become y minus k, so y minus 3, equals plus or minus b over a would be 1 over 2. And then times x minus 2. Remember, this y minus k and x minus 2 part, you can actually steal straight off of your hyperbola formula. It's the parentheses up top if you just take the squared piece off of it. Now, this is all great. My teacher's going to love to grade all that. When I go to graph, I actually don't use most of that because I graph conceptually. So I graph the center. And then, oh, thank goodness. So now, when I go to move along my, what's called the transverse axes, I'm going to move 2 units in that direction. So the major, or the transverse axis here is x, so I'm going to use 2 units in the x direction both ways. So over here, and over here. Should have used blue on there, I'm sorry. Now, I just graphed the vertices. You guys told me the vertices are supposed to be at 4, 3, 3, and 0, 3. Is that where we graphed them?
Yeah.
We're on a roll. Now the conjugate axes, where we're going to finish off the auxiliary rectangle from yesterday, that moves 1 unit in the vertical direction. So 1 unit up would be the top of the auxiliary box, and 1 unit down would be the bottom of the auxiliary box. So kind of finishing off all this, you get your auxiliary rectangle, and this is what I use to help me graph. So the asymptote lines, that's beautiful. I love those equations. I'm not going to use them. I am just going to draw lines through the box. So the diagonals are the asymptote lines. So the only thing you can mess up from here is that you put the branches in the wrong spot. Remember, these initial points that you plotted for me, these are the vertices on the branches. Remember, you have one of these horizontal guys. Oops, I missed. And as far as graphing goes, that's about as good as it's going to get for me. Now, the other thing I didn't actually plot yet would be the foci. Square root of 5 is like approximately 2 point something units. I don't know if it's exactly 2.5. It's about 2.5. Square root of 5 would be 2.2, 2.2, a little over 2. The square root of 4 is 2.236, yes. So from the center, you'd be traveling 2.236 units to mark your foci. Do you think I'm going to get out like my, what do you guys call it in drafting? My scale? No, I can't call it a scale. What is the rule?
No, you can't call it a ruler.
Can't call it a ruler. I'm not going to get anything out to measure whether you went literally 2.3 units away from the center, guys. I don't care that much. The point is that my foci are being hugged by my branches.
Do I have to show all that other stuff?
Queen Elizabeth is the ruler.
It took me so long to figure that when you said that.
Okay. So, what we're about to do, I think these are the harder problems, frankly. These are the ones where you got to write the equation, and I'm going to give you clues. There's not a single problem in this whole unit where I don't sketch something. Because even though my pictures are really crappy, they're enough to help me at least with which formula I have. So we're going to skip the one that's not on your notes, and we're going to do this one that is in your notes. Give yourself a nice little sketch off to the side, and we're not going to graph the whole thing, so literally it's just a sketch. You have vertices at -10, 6 and at 4, 6. So I'm going to pretend this is the ordered pair -10, 6. And I'm going to pretend this is the ordered pair 4, 6. And while they should be relatively to scale, they don't have to be exactly to scale. They should be at least in the right part of the coordinate plane. All right, so, So you just found the center for me, thank you. The hyperbola is going to look something like this, right? If these are the vertices, that means this must be a horizontal one. So what I'm going to do is I'm going to write down the formula, the skeletal formula for a horizontal hyperbola, which is x minus h squared over a squared minus y minus k squared over b squared equals 1. So just like when we were doing ellipse formulas, you have to find the center, which Adam already found for me, thank you. And you have to find a and b. So you really have to understand what the concept of a and b are. The formulas are not really going to help you much here. So Adam, you quickly found the center to be located at -3, 6. Can you talk to me about why you know the center is at -3, 6?
Because from -10 to 4 is 14, and then that's 7.
You did midpoint. Kinda. Sorta.
And then I just added 7 to
You found the middle. You found midpoint. Guys, could you tell that it was a height of 6 regardless of what your math was going to do? So from -10 to 4, if you wanted to find the middle of that, you'd do midpoint. So that's where this number's coming from. Okay? Hey, look what you just stumbled on. That's h and k. So if you wanted to, you could come back through here and you could fill in h and k. Now, h being a -3 makes this factor a +3. And k being a 6 means it's y minus 6 squared. Cool beans. All right, so now let's talk about what does a represent. A is the distance from your center to one of your vertices. So it's half the distance of what we call the transverse axis. So you went from -3 to -10, or you can say -3 to 4. Either way, it's a distance of 7 units. So you just found your a value to be 7. Cool. Go back here and fill that in. Call that a 49. But what about B? I don't know either. B is the conjugate axes. They don't tell me anything about that. But they do give me a clue about foci. Let's talk about that. So your foci is at -12, 6, so like right here, and then 6, 6. The foci, they could help you find the center, because the center's in the middle of those, but we already had that. What the foci are going to help you do is find the value of C. The distance from your center of your hyperbola to one of the foci, so like this guy is -12, 6, that's a distance of C units. So how far did you go from -3 to -12? 9 units. Again, that's not B. But I think A and C can help you find B. Isn't there a formula? It says C squared equals A squared plus B squared. That's straight off your formula card. All right, let's do this. C squared equals 81. A squared is 49. And then plus B squared, which we don't know. And guys, I'll be even lazier than you. I don't actually want B. I just want B squared. So literally, all you got to do is subtract this over. And Daniel told me that's 32. I don't even want that. No, I just want this. 32. Now, if I asked you for B because you had to graph it, yeah, you'd have to go up and down square root of 32 units. No, thank you. So good news, we don't have to graph it. We just have to write the equation. So that's a very typical question of what you'll see on your test. They get a little tricky. And I think sometimes kids don't practice these because they're like, oh, well, she gave me a formula sheet. Yeah, but like if you have to like think really hard about everything you do on these questions, you're going to run out of time on this test, which is the issue.
I have a question.
Yes.
What is a hyperbola called if it's a 3D figure? Like, maybe like a cylinder shape?
Might just be a
Would it just be called a hyperbola scope?
No.
like
It- I think when you go to calc, like this, so if you take like, it's been a long time. This is why I'm retaking calc. No, yeah, kind of. Hyperbolic trough is a thing. There's something called a saddle point, which kind of looks like it.
Okay.
But like, I think you're envisioning something more voluminous looking.
You know what?
Looks like a cup.
You know what the cooling towers look like at the Byron plant?
Yeah, actually,
That's
yes.
that shape.
Yes.
So I didn't know what those shapes were called.
Yeah, I don't know. Why don't you Google that for me? There's a lot of three-dimensional things that are coming your way in calc. So like, you guys are going to you're going to take like, the square root function. You're going to find out what happens if you rotate that around. It's going to create like a shell. If you took like a half of a parabola and rotated it around, it would create kind of a cool shape, right? Those are some things you're going to do in calc. So look forward to that.
Why do you need to move around the square?
There's a reason for it, I promise. All right, let's look at this guy. So this one is difficult for kids because of the vocab here. The transverse axis is 8 units. What that means is the distance from vertex to vertex is 8 units. So let's get a little sketch real quick.
It's a hyperboloid.
Hyperboloid. Who would have thunk it? All right, so foci of 0, 6, and 0, negative 4. So here's what I'm seeing. Foci at 0, 6. And we'll pretend this is 0, negative 4. So my hyperbola is going to be one of these vertical guys. Oops, pretend I didn't hit that. I know. Which means I'm going to have a vertical formula. So make sure you're copying the right one down. The vertical formula starts off with y. So y minus k squared over a squared minus x minus h squared over b squared equals 1. So that transverse axis, that is the distance from vertex to vertex. So this whole distance here is 8. The distance of A, what we know as A, is from the center to one of the vertices. So if the whole distance is 8, that means A must be a 4. So I can come back through here and say, oh, oops, that was supposed to be an eraser. Since A is 4, this is a 16. I would also argue you guys can find your center. So think midpoint. Clearly the x value of your center is 0. But what's the middle of 6 and negative 4? That's a 2 over 2, which is a 1. So now you just found your h and your k. So be careful. This is where kids mess up because they put the 0 here. Is the 0 supposed to go there? That's the k. So the 1 goes here. And then if you guys just wrote x instead of x minus 0, I totally get it. That's what a normal human would do, but I'm going to leave it as x minus 0 squared. So once again, I'm kind of in a jam because all I see is I need b, and I don't have anything about b. They don't tell me anything about the conjugate axes, but they do give me a clue about foci again. So remember, the definition for the value of c is the distance from the center, which we just found to be 0, 1, to the foci. So either up or down. So from 1 to 6, c is 5. All right, so that's going to help us find b. So we're going to use, why do I keep switching colors so crazy? We're going to find the formula off our formula card if you forgot it, but c squared equals a squared plus b squared. So c squared is 25. We already figured out a squared was 16. And all I really need for you guys is to find b squared, which I heard was 9. So yeah, I agree. Ta-da! We're done. Not awful. Not fun. Or is it? No. One without the foci? I mean, yeah, but I'd have to tell you something. I'd either have to maybe the next question. That one has a foci though. What if I gave you vertices and asymptotes? Why would they give me the asymptote? Let's talk about this. Again, I'm going to start with a picture. A really crappy picture, but a picture.
Because where the asymptotes intersect.
True, but I think there's an easier way to find the center. Okay. So we've got foci at 2, -2. I'm going to pretend that's right there. And then at 12, -2. So you're going to have one of these hyperbolas. Ooh, that's super ugly. Okay. The good news is they don't want me to graph it. That's wonderful news. All right. So Adam's finding the center for me. I didn't write anything down. All right. So this is 2, -2, and this is 12, -2. So the center, he's using a little midpoint formula for me. He said 7, -2. You guys see where he's getting that from? Adding up 12 plus 2, cutting it in half. So y'all just stumbled on your H and K. You know what we should identify, though, is what kind of hyperbola we have. We said it's horizontal. So the formula we're using is the x one. Yep, x minus h squared over a squared minus y minus k squared over b squared equals 1. However, we just found h and k, so if you don't mind, oops, that's not an eraser. I'm going to go through and fill that in. So your center being located at 7, 2 would be x minus 7 and y. Careful, this would be a plus 2 right there. Good. All right, cool. Why is this important to me? Look at your asymptote equations. And the slope for this guy, for this horizontal one, this slope is in the ratio of plus and minus b over a. So it would be really awesome if I could just assume every single time that that meant b is 3 and a is 4. But is 3 over 4 the only way to reduce a ratio and get 3 over 4? It could be 6 over 8. It could be 9 over 12. I don't know what it is, but I bet we can figure it out.
Wait, if you multiply, this has nothing to do with it. If you multiply 74 times.
Top and bottom, it would be the same ratio, but it has to be top and bottom. Like I'm just multiplying the ratio, numerator and denominator, by the same number, by like 2 over 2, by 3 over 3. And I'm getting like these ratios that are all equivalent to 3 over 4. Is that what you're asking about? This is going to be another black hole. What if you do this in a black hole? How does the math work? Does it come back to you? In particle energy, perhaps? I'm just making stuff up now. I don't even know what they're talking about. Sorry, I brought it up. Okay. Coming back. Coming back. All right, guys. The only clue they gave you that I think can save us right now is the foci. Can you tell me the length of C? So remember, you have the center. You know this is at 7, -2. So from center to foci, according to this, the C value is 5. Would 3, 4, 5 work for that Pythagorean formula? Yes. So we get to keep B as 3 and A as 4. I'll show you what happens later on when that doesn't happen. On your test, we were very nice to you, and we made sure that this question that has an asymptote, the ratio is the ratio. So like if it says 5 over 7, that means A is 5 and B is 7 or whatever it comes out to, okay? So, guys, I think we're done. A squared would be 4 squared. Careful, 4 squared, because A's on the bottom for this, is 16. And then B squared, that would be a 9. Very good. That was a little weak on my explanation as to why the A and B were 3 and 4. 3, 4, 5 is a Pythagorean triple. That was the first dead giveaway, right? But if you knew C was 5, you could set up a little C squared equals A squared plus B squared to prove it to yourself. Does that equate? Sure does. Okay, so that's why I was like, yes, that's exactly the ratio. 3 over 4. 4 over 3. All right. We're going to skip the earthquakes. I love this question just because how dumb it is. So they're going to make a park play area that's a grassy play area in the shape of a hyperbola. I don't know. Sounds like something Daniel might design, though.
What? Hyperbola? hyperbola.
A grassy play area in the shape of a hyperbola.
Yeah, you know,
Kids love
I
hyperbolas.
I love my kids.
They love hyperbolas, right?
I mean, I've always been fascinated with hyperboloids.
And you know what you could do is you could plant your equipment at like the focal points. Be like, there you go.
This way I can see them at all times.
That's not true.
That's how it works.
It's okay. We're going to move on to our last concept here, eccentricity. Guys, we have officially completed the conics that we were going to talk about, which means you should know everything there is to know about eccentricity. Now, let's talk about this. On your formula card, eccentricity is defined as the distance between the foci over the distance between the vertices. Now, on your formula card, you guys got this. C over A. Isn't that on your formula card somewhere? Eccentricity is C over A. So, where eccentricity formula really comes into play, let's talk about our friend the ellipse from last week. C is technically the distance from the center to the foci, but if you go from C to C, that's a distance of 2C, right? We're okay with that? And then the distance from A to A, remember A being the measure from center to the edge on the major axes? Well, all the way across from negative A to A would be a distance of 2A. You okay with that math?
Yeah.
And are you okay with me saying 2C over 2A simplifies to C over A?
Yeah.
That's where the formula comes from. Whenever we give you a formula in math, it is the simplest version of the formula. Some other mathematician has come through, proven it, derived it, said, boom, here you go. Thanks, math. Now, think about the numbers here, guys. The distance that I'm going to call the blue piece here, relative to the distance from here to here. You have a smaller number divided by a larger number. In math, when you have a smaller number divided by a larger number, what kind of answers are you going to get? Something smaller than 1. So the eccentricity for ellipses are between 0 and 1. So there's questions out there where it says, I have a random conic. The eccentricity is 0.52. What is it? And your answer is ellipse. Because the eccentricity is between 0 and 1. Now on a hyperbola, our friend from this week, the distance between the foci, okay, so here's your foci, right? That distance is larger than this distance, right? So now you're taking a larger number divided by a smaller number. So in math, your eccentricity on a hyperbola is going to come out to something greater than 1. Like 1.2, 2.5, 3.8. And, you know, the more squishy the ellipse, the hyperbola. Huh? Yes. Good transition. So that brings me to my next slide, which I think some of this is on your formula card. This shows that for an ellipse, the eccentricity will always be between 0 and 1. So the way you can write that is this. The eccentricity is between 0 and 1 for an ellipse. On a hyperbola, the eccentricity will always be greater than 1. Because the parabola only has one vertex and one focus, there's not really a distance measurement to do there, so it's like 1 over 1 and it reduces to a 1. That's a little boring. And I think this is magical. A circle. Remember the demonstration over there? And if we were drawing the ellipses, and I said, well, what happens if you bring your foci like closer and closer and closer together until they overlap? What ended up happening when your foci came closer and closer and closer? You got pretty much a circle, and then when they all of a sudden like came together to a center, you literally had a circle. So guys, if there's no distance between your foci, that means your numerator in that E formula is 0. So in math, if you took 0 and divided it by anything, you get 0. And look how magical this is. The eccentricity of a circle is 0. Isn't that magical?
It's so magical. It's magical as a black hole.
Wouldn't it be awful if it wasn't 0? It'd be like the sine cosecant argument all over again. Remember, you guys were like, why can't they
come back in my life?
Yeah. Yes, aeronautical engineer, pilot.
No.
Pilot? You don't think you'll ever see a trig function again? Nice try, man.
Astrophysicist.
Yes.
I think I really can.
Haven't you seen Neil deGrasse Tyson?
Yes, I think you can be anything you want to be, Taylor. I mean,
I'm just asking.
on the side, astrophysicist, bodybuilder.
Go to competition to just blow people's minds.
There's a lot of physics involved in sports. All right, guys, you got a lesson to do. Now, this note, get rid of this. This is gibberish from years ago. We don't do that. You do have that assignment. It's a little bit of like complete the square. Tell me what kind of conic you have, and then it's a little bit of eccentricity work. I don't think anything on this assignment creates graphing. I don't think you have to graph any of it. That all was on yesterday's assignment. Guys, please promise me that you'll practice this. I know you're like, oh, it's easy. There's a formula. It's not easy because you're not fluent in them yet. You gotta be fast. And remember, all that trig crap comes back on the next test. Ugh.
I'm not gonna need
Friday.
to
Well,
computers.
Tuesday at like 4 o'clock, but the grade book cuts off on Friday. You gotta. Oh man. All right. Well, we should make that up. All right. Good luck.